Hello viewers, from today we will start classical mechanics. But before that I want to discuss some aspects of Newtonian mechanics. I want to review all that Newton mechanics for you in order to begin this course. For the example, for a pulley, let's say this mass be m2 and this be m1, where m1 is greater than m1 mass is greater than m1, so the force will act like this in that condition, downward, and the tension to the string is upward T. And if a pendulum is oscillating, say in this way, then this time force will be in this direction and the tangent in along the length of the string. Now in this case we have to resolve this component to equate the equation of motion. So basically our strategy in Newtonian mechanics is, first we draw a diagram. Second thing, we identify all the forces which are in action. Identify all forces. Third one is work out net forces, as in this case we will find net forces to equate the equations. Work out net forces. Fourth one is we use Newton's law, use F is equals to ma to find acceleration. Fifth one, we integrate all the equations to find trajectories. Integrate all equations to find trajectories. So the central problem in classical mechanics is to central problem in classical mechanics is to find trajectory of particle. And what do I mean by this trajectory? As it is denoted by r of t. It denotes the position of in three dimension by x, y, z coordinates, and it depends on one parameter t. As this remain invariant here, but as we move in relativity, the time will not remain invariant, and the derived quantities are, first one is velocity, which is v to t and can also be r dot t, dr by dt, dx by dt, dy by dt, in order to represent this dz by dt. Okay. And the another quantity which can be derived, acceleration, which is a to the function of t, also a vector quantity, and can be represented as v dot t, or we can say r double dot of t, and d square by dt square r of t. Now in the column form we can write this as d square x over dt square, d square y over dt square, d square z over dt square, which is equals to ax, ay, az component of the acceleration. And the fourth quantity, which is linear momentum is simply p is equals to mv, where m is a scalar quantity, and by knowing that v and right quantity, we can also evaluate the linear momentum. Same stands for the angular momentum, which is L r cross p. So the more thing is that if we know the trajectory, so if we know trajectory of r of t, we will know these all derived quantities. So how to find this trajectory? So the answer is that by Newton's law. And what are these Newton's law? First law, you all know that v remain constant if f equals to 0, which is Galileo principle of inertia. Second law is f is equals to dp by dt, which we can say that p dot is equals to ma, where m is constant. And this law came from the experimental evidence which was judged by Newton at that time. And third law, which is well known, is that every action there is an equal and opposite reaction. So which is equals to say two bodies force on 1 by 2 is equal and opposite by 2 on 1. And in the next video we will discuss some conservation laws. Thank you.